Hello, everyone. It is my pleasure to introduce our speaker, Dr. Choe. Dr. Dong-Hwan Choe is a professor of entomology at UC Riverside. His research focuses on three major areas: urban entomology, insect behavior, and chemical ecology. In particular, his research has focused on exploring innate and learned behaviors of economically and environmentally important insect species to develop more effective integrated pest management programs. He uses manipulative laboratory studies to investigate how the behaviors of pest insects can be exploited to improve management and to develop novel management techniques.
We have been collecting from one of the recent projects. We got funded from the DPR, and also I want to highlight some of the important aspects that from the project that could be actually implemented for practical pest management. So ants are actually pretty important urban insect pests. Based on some of the recent market survey that was conducted by Pest Control Technology magazine. This was the actually nationwide survey. Most pest management companies provides ant control services. So 97% respondent said they offer ant control. In fact, the ant control is actually a pretty important part of their residential and commercial pest control services, partly because it's quite beneficial in terms of business perspective, but also it's pretty widespread and also consistent issues in urban settings. In California, we are not an exception. So we also have ants as the major urban pest throughout the California. But most of these ant services are kind of highly focused on in fact, some of these ants are actually more common in Southern California than the others. So depending upon the locations, even within California, we're probably targeting different groups of insects, ants, as a major pest groups in urban settings. This is another survey that was conducted by Pest Control Technology magazine in 2023. And the survey asked, in the past 5 years, have ant control service become a more or less significant portion of your location's business? And more than a half of the respondents said the ant control businesses or services become more significant over last 5 years. So that means the ant control has a bright future in terms of business perspective as well. In addition, the ants are considered as one of the challenging insect to control. And we can kind of, we can say that based on this survey data, this survey is about the callback rate. So this is the national average for callback rates for pest control services. And these are different target pests. So termite, bedbugs, wildlife, and cockroaches, etc. And at the bottom of this chart, you see ants. So national average callback rates for ant control is over 5%. It's about 6.3% based on this survey, which means the customers is more likely to be unsatisfied when the target pest is an ants, and then whatever control effort has been implemented to control that ants. So that means ants are difficult pest groups to manage. This table shows the different species of ants And the survey actually asked this particular question: what ant species represent the largest percentage of your location service in 2022? Depending upon the locations of the United States, the answer has been quite different. If you look at the West, the most important, the most commonly mentioned ant species was Argentine ants. So almost 40% of the respondent said Argentine ant represented the largest percentage of the ant service in 2022. And it's followed by the border south ant, which is also quite a challenging insect to manage, and also followed by payment ants. So without doubt, the Argentine ants are important ant pest groups in California. In certain part of the California, especially southern part or San Diego or Orange County, the most of the ant calls are related to Argentine ants. So this particular survey conducted in mid-2000s reported the specimens the technicians have collected, most of them were Argentine ants. The pesticide application is still the main tool to manage pest ants in and around structures. Based on this survey conducted in 2023, 98% respondent mentioned pesticide applications as the tool to control ants in homes and businesses. This include bait and spray and granular insecticides. So among all those different types of insecticides, the spray is still the most commonly used insecticide formulation for outdoor Argentine ant control based on our internal survey. We kind of know why that's the case. First of all, the spray insecticides are easy to use. The only thing you need is a spray backpack or any type of sprayer. You just mixed with insecticide with water, and then it's ready to go. And also, it can treat larger areas, and then in a relatively short amount of time. So that also relates to cost effectiveness of the treatments. So it's easy to use, and it's relatively inexpensive to treat large areas. So that's probably the reason why the sprays are still commonly used for ant controls in many parts of the California. The DPR and other agencies are always monitoring the insecticide levels in surface water systems. And based on their research and monitoring efforts, we know that some of these insecticide active ingredients are detected in surface water system throughout California. So the graph here is the left bars. These are the detection frequency of these insecticide active ingredients in the water system by itself. And then the right ones shows the detection frequency of these insecticides in sediment at the bottom of the water. So if you go through the list of these insecticides, we see fipronil here, and fipronil sulfone, that's the metabolites of the fipronil, and permethrin here, bifenthrin. Both of these are pyrethroid insecticides. And all insecticides shown here on the sediment side, bifenthrin, permethrin, cyphlothrin, and go on. And these are all the pyrethroid insecticides. So as you can see here, these insecticides are relatively frequently detected throughout the water system, surface water system throughout California. Since these insecticides are commonly detected, the regulatory agencies suspected that some of the insecticides that are used in urban pest management are, at least in part, responsible for this insecticide runoff into the surface water system. So the regulatory changes had been made in recent years. The first one was urban surface water protection regulations for various products containing pyrethroids. That was implemented in 2012. And then more recently, the US EPA approved a new label amendments for the spray product that contain fipronil as an active ingredient. And also they approved the California specific use restrictions. If you look at the more details of that California specific use restrictions for fipronil containing spray products, the application rate is now reduced from 0.06% to 0.03%. And application can be made 4 times per year, but no less than at 6-day intervals. Perimeter foundation spray need to be 6 inches up from foundation where the foundation meets the ground, and then 6 inches out from that interface. And the rainy season, the fipronil insecticide cannot be applied during the rainy time of the year. We're actually towards the end of this period. And then some of these areas that are really close to surface, impervious surface, cannot be treated with fipronil insecticides. So as you can see, there's a lot of limitations in terms of use these insecticides for outdoor applications. But now the problem is whether following this label provides effective end control outdoor. So in our program, we kind of followed, we kind of tested this application method in the field by following this label instructions. So in 2021, we conducted this field study where we used 0.03% fipronil spray, perimeter spray, and then followed by the 0.06% bifenthrin spot treatment applications around the home to see whether those 2 applications that are separated by about 3 weeks provide sufficient control for Argentine populations. These are 5 different houses, so there are 5 lines here, and we start from this the number 1. That's the start, the baseline end activities, and we made fipronil application. Some houses got some reduction, but others have increase in end activities. And then at week 4, we made another follow-up treatments using bifenthrin spray. As you can see in this graph, some houses got some reductions, but not all of them. So there is a huge amount of variations, even among these 5 houses. So our concern now is that just following this label instruction may not provide sufficient end control, and possibly resulting in callbacks, customer unsatisfaction, or repeated application of spray insecticides. On top of all of this, we all know that homeowners use their own DIY application of insecticides. So based on this recent survey conducted by DPR personnel, reported that at least 30 or 35% homeowners in California apply the over-the-counter products containing one or more pyrethroid in a regular manner. And homeowners also reported ants are the most commonly reported, the ants as the most common pest around their homes. So we're in difficult situation. We try to discourage homeowners to do their own DIY pest management, unless they have some ants indoor and they can use a little bait inside of the house, but we typically discourage the homeowners to buy a spray product by themselves from store and then apply around the houses. And then the pest management professionals are encountering stricter and more complicated regulatory requirements. So in this, the project that was recently funded, we call it Ant IPM Alliance Project. We teamed up with pest management professionals and chemical manufacturers to really develop some new protocols that implement the low impact strategies for ant IPM. In this particular project, we adopted two modifications. The first one was the use of pheromone adjuvants for non-repellent insecticide spray. And second modification was active incorporation of bait for follow-up and manage the maintenance visits. To justify these two particular approaches, we have to think about the biology of ants. First of all, the ants are chemically oriented animals. As you see in this little video clip, these are all Argentine ants following their trail. They're following in massive numbers in these trails. And they're not really relying on visual cues while doing this. They're strictly relying on, or mostly relying on the chemical cues when they're following these heavy trails. In Argentine ants, we know ants use this very particular compound as the aggregation pheromone or trail following pheromones. So these are aldehydes, simple aldehydes. It has a double bonds somewhere in between carbons. This aldehyde pheromone is produced by ants in small quantity in this small glands they have at the tip of their abdominal regions. So while they walk, they release the chemicals, making the other ants can follow the ants in front. The really excellent thing about this pheromone is very easy to synthesize in the laboratory. And it's so powerful. So if you apply that chemical in a line, the ants will follow that line without any mistake. So here we applied very little of these pheromones, and you can obviously see the powerful action of these pheromones in terms of its effect on the ant behavior. By exploiting this insect's behavior, in particular this Z9-hexadecanol, the pheromone, and Argentine ants' behavior towards that chemical, we can develop these attract and kill strategies. So in attract and kill strategy, we combine insecticides with chemical lure in a same spot. And as a result, we basically attract the insect to insecticide deposits and improve the efficacy So use of this pheromone as an adjuvant in a non-repellent spray has been actually tested in the field by larger company. And according to their data, adding this pheromone in the first non-repellent insecticide barrier treatments provided a huge amount of reductions, significant amount of reduction in callback rate for the commercial and residential routes. So what we are guessing as optimal or the ultimate, the consequences of this, the improvements is the reduction, the need of frequent reapplication of the spray product. So by using this pheromone adjuvant, the companies will be able to expect the reduction in repeated spray applications for maintaining ant numbers low. The second important aspect of ant biology we need to consider is the adult ants' feeding preference. Adult ants are all liquid feeders. Even though we often see ants carry little bits of cookies or little bits of whatever, those solid particles are usually provided to their immature insect larvae as a food sources. The adult ants, they can handle the liquid food most effectively. So the worker feed on liquids. Those liquid could be sugary liquid or the oil-rich liquid. In this Argentine ant shown in this picture, they're drinking a large amount of sugar water and then store that sugar water in the specific organ known as a crop. So they temporarily store that sugar water in the crop and they share those sugar water when they go back to their nesting sites. So we call this crop social stomach because ant and other insects, social insect, actually utilize this crop as an important way of maintaining the intra-colonial communication and interactions. So frequent sharing liquid food between colony members are important characteristic of ant colonies, including Argentine ant colonies. That particular feeding habit is not really surprising if you understand that some of these ants are naturally adapted to sugary liquid. So in this picture, you're looking at the Argentine ant collecting honeydew, which is a sugar-rich secretion that is produced by aphids or scales and mealybugs. And since they are already adapted to this type of food, it's not entirely surprising that the sugar baits are effective way of developing bait targeting Argentine ants. In the case of fire ants, as you can see in these images, they love this oil, the oil-rich fluid. These are the Solenopsis fire ants I found in my backyard. And when I provided the peanut butter, they all gather and then start licking those oil out of that peanut butter, little peanut butter, dab of peanut butter. And over time, they're going to take out all the oil from peanut butter, and then they're going to leave little crumbles like this. So what they're actually going after is the oil portion of this peanut butter. And this is the Argentine taking the sugar water. So again, this particular portion of their digestive system, known as a crop, this is the important part for ants to temporarily store this liquid food for sharing with nestmates at a later time. In some ant species, this crop has been evolved to serve as the storage organ for a long term. So in this honeypot ants, these particular individuals actually function as live containers of the large amount of honeydews that are collected by nestmates. And then they all transfer the honeydews into these individuals, and then they kind of function as the living pod or storage organs for their colonies. And then they share this liquid food eventually with their nestmates. So in this picture, you're looking at the Argentine ant sharing liquid food. And this action of sharing of liquid food is known as trophallaxis. Troph means the food, and the axis means the transfer. So these are literally means that the sharing of food among different nestmates. So considering all these, the ants, the worker ants, adult ants' preference for liquid food and their sharing inside of their colonies. And also the Argentine ants are known not having the intercolonial aggression. So they function as a big, gigantic, massive one populations without having any the intercolonial internest aggressions. They don't fight. So they will share food even among different nestmates. So considering all these facts, the bait really can serve as the much targeted approach for Argentine ant management compared to insecticide sprays. So think about the bait that is applied in a point source in the field and comes and they take the toxicant along with the food, and they're going to bring those things and then share. So you see the transfer effects. So these are transferred to other individuals, and then it's going to cause secondary or tertiary mortality, providing effective management for ants. On top of that, the bait has some interesting advantage because the bait can be used in the locations where the perimeter spray cannot be used. So think about the fipronil. We cannot apply fipronil away from the structure. It has to be always bound to the structure foundations. But bait can be used away from structures. Gel bait, liquid bait, those things can be used away from the exterior foundation walls. So I think that bait can really serve as effective strategy for maintenance services. And the bait has been tested. In this case, it's not really commercially available formulation, but we tested 1% boric acid bait incorporated into the hydrogel in the field, and we demonstrated this bait can actually serve as effective means of maintenance services. So look at the first graph here. This is kind of similar graph that we saw in the earlier slides. The y-axis here is a number of ant visits. So that these are the indicator of the ant pressure in a house, and the pre means a pre-treatment before making any insecticide application. Week 1 means week 1 after the first insecticide application. So in this first group of houses, we used 0.03% fipronil as the perimeter spray, as the first treatments, and then we followed that up with 0.06% bifenthrin spot treatments. The N number went down a little bit, but went up, and then it wasn't impacted by bifenthrin spot treatments at all. In the second group, we did this exactly same thing, 0.03% fipronil perimeter treatments first, and then we followed that up with botanical oil spot treatments. And you can see the N number did not really show any significant change over time. In the third group, we use a fipronil plus pheromone adjuvant for the first treatments, and then we followed that up with 1% boric acid in hydrogel. You can see a significant reduction in the first treatments, and also you can see the N numbers maintain low after the second follow-up treatments. So this has been demonstrated based on the field study. So 2 approaches, pheromone adjuvant for non-repellent spray. This strategy will be effective, particularly when the ant infestation level is relatively high. The bait may not provide substantial control, or especially when N numbers are extremely high. But once you push down the N numbers to a certain level, from that point, the bait can be used to just keep the N numbers low without the need of repeated application of insecticide sprays. So that's the 2 approaches we implemented this alliance project. So think this as the typical conventional application of plan. We treat, N numbers go up, show up again, make a second application of spray, went down a little bit, when N numbers go up again, you make another treatments of spray, go down and then go up again, and another spray. So these are 4 sprays used throughout this conventional route. What we want is we provide good control, initial knockdown, by really maximizing the impact of the first spray treatments. And then we follow up with bait use to keep the N numbers low throughout the end seasons. So that's the idea in our approach. So in this Ant IPM Alliance project, we formed an alliance team with participating pest management professionals and industry members and academia. And we really encouraged the pest management company members to develop their own effective low impact protocols for ant management. And we asked them to implement that 2 particular approaches, pheromone adjuvant and active use of bait for maintenance services. And then we collected the data, pesticide use data and callback data, etc., by working with those pest management companies. And then we plan to promote these low impact strategies by conducting workshops in the later in 2024. So as of today, we have these companies as the alliance team members. We have Clark Pest Control and Pesttech as the pest management company members. And then we have Sotera, MGK, BSF, Enview, and Syngenta as the manufacturer members for this project. So these are some of the progress we have been making in 2023. We discussed the core protocol requirements with participating pest management companies. And we worked with manufacturers to provide all this necessary bait products and pheromone product to pest management companies. And the pest management companies set up 2 separate residential service routes, and they used one route for low impact route, and then they used the other route for conventional route. So we collected data from these 2 different routes to compare them. So these are the data that were collected, insecticide use patterns and what kind of insecticides and how much we use, and also what kind of callback we get, and then we can calculate the cost information based on type and amount of insecticides used, but also the time the technician spent to make these treatments. In 2023, one company used 75 accounts for conventional route and 70 accounts for low impact routes. And we have been collecting data. So these are some of the preliminary data we have been getting so far. And this is for standard route, the conventional route. These are the number of applications of insecticides, neonicotinoid, pyrethroid, pyrethroid 2. So there are two different types of pyrethroid sprays used, and fipronil. So obviously what you can see here is that number of application for pyrethroid is very high for their standard route. In low impact route, in contrast, we didn't have any pyrethroid, at least for ant control, but they used this neonicotinoid spray as the spray product, and we used some of this ant bait as well. If you look at the total amount of insecticides used or applied, again, for standard route, we see a large amount of pyrethroid 1 spray product, almost 6,604 milliliters of the concentrate has been used, and then some smaller quantities for other product, including neonicotinoid spray and fipronil spray. For low impact, again, the largest quantity of insecticides used was found for neonicotinoid spray product. It's expressed in grams of the product. It's 940 grams of product. If you look at the average amount applied per application, so this number is calculated by dividing the total amount applied by number of applications. Still, the pyrethroid was it represented the largest amount of insecticides applied in standard route. In low impact route, the neonicotinoid was the insecticides that was applied in the largest quantity per application. Interestingly, if you look at the callback rate, our low impact route with modified protocol had overall lower callback rate, about 2.5%. In contrast, the standard route had about 8% of callback rate. If you only look at the ant-related callbacks, the low impact route had 0.6% callback rate, while the standard route had about 3.6% callback rate. So overall, in terms of customer satisfactions, our modified low impact route was quite comparable or even better than the standard route. We have been doing some preliminary economic analysis. We look at the average time spent per visits, and for low impact, average time spent per visit was about 31 minutes. For conventional route, it was about 32 minutes. So it's a very, very similar amount of time needed for treating each account. And we also looked at the product expense needed for each visit, and it was very similar between low impact and conventional routes, about $2 to $3 range. So some of the other additional considerations was that in 2003, the bait use was very minimal for low impact routes. So in 2024, the Alliance team communicated on this, and then we are planning to really emphasize the incorporation of bait for low impact protocols. So these protocols will be further modified for 2024 field demonstration and implementations. As we expand the use of bait for field applications, the most important question that needs to be asked and answered is where to put the end bait. This is particularly important information to educate the technicians who's going to be actually applying the bait in the field while they're making their visits. If you think about the complex and relatively large, the backyard and front yards of these residential settings, it may not be that straightforward to really determine where to put these end baits, unless there is existing end bait stations that just need to be simply maintained and serviced during the visits. If you look at the label information of some existing bait products, these are just typical expressions shown there. Place bait on, into, or adjacent to structures where ants are observed, adjacent to ant trails, and to the areas suspected of ant activity. In other products says locate areas around the building where ants are seen trailing, apply the bait in areas inaccessible to children and pets. For perimeter defense system, place bait stations near the foundation or where ant trails are found. So in essence, these label instructions imply that you have to know where the ants are to place its bait. But those are not that simple, especially if you think about sunny, warm day, even hot day in Southern California. Ants are not going to be out there and just, trailing in plain sight. They could be hidden. They could be like in certain locations. So the question is how to place the ant bait most strategically, even without searching for ant trails. Would that be possible? It might be possible if we understand where the ants are most likely to trail. Interestingly, if you think about the residential gardens or settings, there are some common structural characteristics or items. So in 2023, in October, we did this simple study in UC Riverside campus by determining location types based on the characteristics. So we determined these 5 different location types based on the single characteristics. So the L stands for lawn, C stands for concrete, and D stands for dumpster or trash can, and T stands for tree, at the base of the tree, the plant that has a trunk, and V stands for vegetation or bush, which the plant that doesn't have the large trunk. And then, so these are the pictures. It's a lawn, and this is concrete. But the things you are seeing on the top of this concrete, these are our monitoring squares, little cotton squares that is soaked in 25% sugar water. So if the ants find it, they're going to be gathered around here. So we can actually count how many ants we're going to get on that monitors. So that's a concrete. And dumpster, as you can imagine. And these are the tree, the plant with the trunk. And V stand for vegetation bush. And then we also identified 5 additional location types. And these locations are characterized by the presence of 2 important surface characteristics and their interface. So LC stands for lawn and concrete interface, and SC stands for soil and concrete interface, and MC stands for mulch and concrete interface, and BS stands for building and soil interface. So in this case, building is a vertical concrete surface, unlike concrete here, which is horizontal surface. And again, the BC is a building and concrete interface. So we placed the monitoring, the squares in those locations, lawn and concrete interface, soil and concrete interface, mulch and concrete interface, building and concrete interface, etc. So we placed the monitors there, and then we came back in an hour, and then we counted the total number of ants on those monitoring squares. And we repeated this somewhere between 7 times and 15 times for each of these sites. And this graph really summarized our findings. Look at this largest bar here. The most of the ants, the highest number of ants, were consistently found in LC, which is the lawn and concrete interface. So this study finding indicates that lawn and concrete interface is the best site to place the bait. This lawn and concrete interface provides structural guidelines for ants for trailing. A base of tree is another nice location, especially if the tree have honeydew producers in the canopy. The ants will have heavy traffic along the bark of the tree, the trees. And dumpster site could be good site, but it can be hit or miss. Look at the large, the variations found in our data, which means if there are trails that can be really heavy trail, but some dumpsters didn't have any trails at all. So it could be a hit or miss, depending upon the ants are actually trailing inside the dumpster or trash can to get any type of food. But the LC was relatively consistent with largest number of ants. And lawn and concrete interface are really common structural the characteristics you would expect from the homes and gardens. And this interface may provide preferred microclimate conditions such as high moisture, relatively low temperature for trailing ants. So that's probably why the ants actually prefer this structural guideline for trailing. And if you think about it, this will have a relatively high humidity because of the lawn will get water. But also it doesn't have any heavy vegetation there, so the ants can trail without having too much obstacles. And it could be partially shaded, so it may actually help to cool down a little bit. So it's just kind of nice location for ant for trailing. This environmental factors of that particular location may be also beneficial by keeping the bait or liquid or gel bait palatable, edible for ants for extended period of time. And if you think about the other spray product, those spray product may have strict limitations when treating those locations, which is very close to impervious horizontal surface. So think about, using bait in those locations instead of making spray applications. So bait can be applied to the areas that cannot be sprayed easily. So in 2024, we have been communicating with this participating pest management companies to make adjustment and continue their field implementation of their low impact IPM protocols. We're gonna be continue collecting data by working with their company, insecticide use patterns, callback rate, and customer satisfaction, etc. And as I said, in the later 2024, we will be organizing 2 educational workshops, which will be free for the attendees, to really kind of disseminate our findings and our lessons learned. So if your company is interested in participating in this project as a team member, please let me know, and we need your active participations. So I'd like to thank to all the project members here. We have Chayang Lee, Mike Rust, my staff members, and Carrie. And these are the industry members of this project. And the funding came from California DPR. So thank you, everyone.
Thank you very much. Very interesting talk. And